Hi, welcome back for a physics problem with Dr. Reveles. Here we have two charges, sodium positive and Cl negative, and the question is what's the total electric field at the middle point between sodium positive and chlorine negative? Well, electric field is defined by the equation, which I'm writing here, and we can calculate the total electric field, which will be E total, is a vector, will be the sum of the electric field coming from sodium, which I'm going to call E1, plus the electric field coming from chlorine minus. So remember, these are vectors, have directions. By definition, for a positive charge, the electric field points away from the positive charge. This is my arrow for E1. And a negative charge, the electric field points towards the negative charge. So I'm going to use the equation for the electric field, which I have here. Electric field equals constant charge over the distance squared. Well, constant charge, over the distance. Now notice that the distance will be half of whatever r is, which is 2.4 angstroms. So I'm going to say that is r over 2 squared. And that's going to point in the I direction. So it's going to point to the right. This is the electric field coming from E1. I'm going to write here E1. Plus the electric field coming from Cl minus, which is again now constant Q over, is the same distance because it's halfway, R over 2 squared. And also is pointing right. J. See, this is the second electric field. I'm going to say this is E2 is also pointing right. So you will need to add both of them in the x direction. So substitute. Now, Q is the same for both of them because consider that sodium lost one electron, chlorine gained that electron, so the charge for them is the same, which is the fundamental charge. This is 1.6 times to the negative 19. So I'm going to write here now, total electric field will be twice K Q over R over 2 squared, and adding them up into the y direction, in the x direction, sorry. So substitute the numbers will be 2 times, constant is 9 times 10 to the 9, that's Coulomb's constant. Q is 1.6 times 10 to the negative 19 over the distance. Now the distance has to be in meters. Remember, because you're using metric units, the conversion is 1 Armstrong equals 10 to the negative 10 meters. So for this case, they tell me they are 2.4 angstroms away, so it will be the 2.4 times 10 to the negative 10 meters. So that's what I'm going to substitute here. 2.4 times 10 to the negative 10 over 2 and all that square, because according to the equation, that will give me the total electric field, which is 2 times 10 to the 11 newtons per coulomb. That's E total, and that's going to be in the I direction, so it's in the x direction. Now, my second question will be, what is the direction of the electric field? Direction of the total electric field, of course, we can add, so the E total direction, we already did that, was E1 plus E2. So really all we have to do is add these two arrows. So I'm going to add the arrows. So it will be E1 plus E2. So total is a bigger arrow, which is E total, pointing left to right. And the size of the arrow, of course, size of that arrow is only one direction, will be this 2 times 10 to the negative, the positive 11 newtons per coulomb. Okay, thank you for watching.